All right, let's do problem number 3 on the practice final. And here it is right here. It says a crate is being pulled in opposite directions and a tug of war is shown below. Use the 5-step procedure to determine the acceleration of the crate. And there's a problem very similar to this coming up in just a little bit. So given. So here's our flat surface. And let me know if I go off screen. Okay. So here we've got a 100 kilogram crate. And this is being pulled this way with 1,000 newtons of force. This is being pulled this way with 300 newtons of force. And we're given a coefficient of friction of 0.3. And what we want to find is, quiet please, be quiet. We want to find the acceleration. So let's solve it. So I'm going to draw a free body diagram. I'm going to use the procedure. This is step 1. Step 2, draw the free body diagram. So we've got the gravity pulling it down. We've got a normal force supporting it. We've got 1,000 newtons like this. We've got 300 newtons like this. We also have, oh, hold on. I'm going to put the 300 newtons like this. But then we also have this force of friction, trying to keep it back. And that's it. Those are all the forces. Let's make to the right positive x. Let's make positive y. Now, the next step of the procedure, this is step 3. Step 4, let's sum the forces in the x direction equals ma in the x direction. And this is what I'm looking for, that acceleration in the x direction. So let's add up all the forces. Look at the free body diagram, and I say, all right, in the positive x direction is 1,000 newtons. And then we have minus 300 newtons. And then we have minus the force of friction. And that's going to equal ma. Oops, screen a little bit. So again, when you're using that procedure for force, this is just telling me what to do. Hey, add up all the forces in the x direction, set it equal to ma in the x direction. Now you have to check, is there acceleration in this problem? Yeah, there is. I'm asking you for it. Now the problem is I don't know, I can move on to step 5, I suppose, and say, well, A is equal, 1,000 minus 300 is 700 newtons, minus that force of friction divided by the mass. And that'll be my acceleration. I'll ask one more time for quiet while I'm recording. But we need to find that force of friction. The force of friction is equal to mu times the normal force. Now, I can sum the forces in the y direction equals ma in the y direction. And that'll, there's no acceleration in the y direction. And you can just look. Hey, the normal force is just supporting all the weight. There's nothing else. So I'm just going to skip that step and just say this is 0.3 and that the normal force is just equal to mg. And m is 100 kilograms and g is 9.8 newtons per kilogram. So the force of friction is equal to 0.3 times 100 times 9.8 equals, and you get 294 newtons. So now I can solve for A. 700 newtons minus 294 newtons divided by the mass, which is 100 kilograms. So 700 minus 294 equals 406. Divide that by 100, and you get 4.06. Now, if you put newtons per kilogram, I'll accept that, except that's really not proper. This is an acceleration. Newtons per kilogram is how we measure gravitational fields. Like how strong is gravity? Well, it pulls with 9.8 newtons of force per kilogram of mass. But this is really an acceleration. It's the rate at which we're changing velocity. So it's meters per second for every second, or meters per second squared. And now we're done. Now on a final exam or something like that, I could say, if it started from rest, how far is it going to go in 5 seconds or something? You can use the kinematic equations with that acceleration. Any questions on number 3? Okay, that is all.